Yeah, so we did talked about a lot of what some of you just mentioned. So what we're going to do is build on top of that. All right, we basically went on and discussed these right here. We stopped at the digital signatures, and we're going to pick up from where we are until we get to the end. Today we're going to have to finish the whole thing. So talk about PKI and what is it, and go into the certification authorities and digital certificates until we get to obfuscation and blockchains. Anybody here investing in cryptocurrency? Thumbs up. You don't have to speak. No, no Bitcoiners. Okay, well, blockchain is going to be that section where we're going to come back to that as well. Anyway, so this is going to be interesting, very, very important chapter that you need to kind of familiarize yourself with. So let me get to the place where we were. What, did I skip something? Yes, I did. I think we stopped here. Does somebody know where we stopped? I believe we stopped at the PKI.
Yeah, you're right.
PKI. Okay,
Yeah, we stop here.
love it. Okay, so PKI, public key infrastructure. Before we dive in and talk about the public key infrastructure, what it is and the other technology behind it, is important for you to kind of reboot your mind a little bit of what we talked about last time. So we did talk about what cryptography was and how it's all the science and the art of encrypting things or creating secure systems. And we talked about cryptanalysis, how that is the science and art of testing those secure systems, see if they're gonna give up, if they're going to break. Basically, we're going in and we are analyzing, we are breaking things without the key. That's the thing, without the key. So we're abusing those systems, we're abusing those algorithms to see if they're going to give up. Then we dive into the concepts, plain text, ciphertext, encryption. These are important. You've got to remember them for so that you can have conversation with other professionals. It's like the OSI model. When I say, oh, that's a layer two problem, I expect you to know that's a switch problem. When I say that's a layer four the layer four problem, I expect you to know that's a firewall problem, and so on and so forth. So the same thing here. When somebody says a plain text, they expect you to know that they're talking about an unencrypted message, a message that is original that have not been encrypted yet, and so on and so forth. So if this is your first time here, or if you're still not haven't gotten these, please go back and review that as well. Then we talk about symmetrical and asymmetric, and these are important. You got to know which key is used where. You got to know that symmetrical is fast. It's used for bulk of encryption, meaning a large of data. You got to know the differences between symmetric and asymmetric because of that. It's going to be on that exam. Then, remembering that, that leads us to the digital signature is definitely going to be on that exam. I feel like we've talked about hashing over and over again. So let's dive into the PKI. So all that technology is great. All creating cryptography and testing them and making sure that they're working. All that is great. But how does this look like in practice? How are we able to buy things on the web without anybody looking at our credit card? Well, that's where PKI comes in. This is the public key infrastructure. It's the infrastructure that brings everything together to make to make the internet secure or to make cryptography work on the internet. So there's a bunch of players, a bunch of entities that gets involved in order for all these things to function. And those entities is people like a GoDaddy, who happen to be a certification authority, and Entrust, right? These are all companies. They're all part of the PKI, and their goal is to make the internet secure by establishing what we normally call a trust or a root of trust on the internet. Because check this out. When you visit a website, when your browser visits a website for the first time, that browser doesn't trust that website, doesn't trust the server that's serving that website. So how do you get your browser to trust that website? Is the answer PKI solves. I sort of mentioned a little bit of it when we were talking about, last week when we mentioned about Bank of America, if you remember. What happens, or what I sort of explained the last week, is what takes place with the PKI. So for PKI to work, we must have entities or companies that are trusted on the web, right? Companies that are trusted by pretty much everybody. And that's really what a certificate authority is, or a CA. Certification authority is an entity that issued what we normally call a digital certificate. They issue these digital certificates. I like you to think about these as digital drive license. So they issue these and they tell everybody, look, if somebody presents you a digital certificate that we, as a certification authority, have signed and approved, you should trust them. You should trust them. Why you should trust them? Because you trust us. Why you trust us to trust them? Because we've done our homework. We've asked who they are, what's their domain in the case of a website, or what is the domain and who owns the domain and their address and all that stuff before we give them the trust, before we basically tell everybody, hey, look, you can start trusting this person. For you to understand this better, I want you to think about the DMV system in America. Who can come off mute? Those in America. Who can come off mute and tell us how the DMV system works? What do you know of the DMV system?
Well, Professor, it starts off now by you got to have so many points. And you get the points by either your birth certificate, marriage license, things of that nature to produce the points. Once you get the points, you register for your license. Once you've registered, they not implement, but they issue a new license if you already have an existing license.
Love it. Love it. Yes. Basically, all you're saying is before they give you that drive license, they have to verify who you are. They have to ask you about, birth certificate, where you were born, and things like that. Same thing takes place here. But here is the beauty. Here is the beauty. Eugene, what happens once they give you that drive license? What happens when the police pull you over?
The license says that you are who the picture say you are.
What happens if this police is from another state?
He still has to honor that because that license is through the DMV, which is an agency that says you are, validates you.
Love it. So do they honor that? Do they trust that because of you or because the DMV?
Because of the DMV.
Because of DMV.
Bingo. Bingo. That's exactly what happens when you visit websites on the web. As soon as you get to a given website, well, there is no trust because anybody can just show up and be like, hey, this is me. Hey, this is my drive license. You're like, well, hold on a minute. How do we trust your drive license? Well, I got these from the Atlanta DMV. Well, okay, I guess that makes sense because we trust the Atlanta DMV. That's the same thing here. Whenever you want to be trusted online, you have to go to a digital certificate, blah, blah, blah. You have to go to a certification authority to tell them, hey, I want to be trusted online, and I want you to give me something that everybody, as soon as they see it, they're just going to give me that driver's license. As soon as they see it, they're going to trust me. They're going to know that I'm secure. And what the certification authority does, they give you this digital certificate. Think of the digital certificate as a drive license. So what happens is similar to what Eugene was explaining to us, the CA, certification authority, they're going to validate the identity of you before giving you that drive license. The same thing happens with this digital certificate. Before that website, www.francois.com, before you are going to be trusted and start using HTTP with the S, we are going to ask you, hey, do you actually own this domain? Where did you buy it from? Right? Did you? And if you are like a company, like PayPal, for example, a lot of a banking company do this. We're going to take that to the next level. Just asking you if you own the domain is not going to be enough. We're going to validate your physical buildings. We're going to do extra stuff to make sure you are fully who you say you are. And therefore, do something like what you see here, where they put the company name in the browser. This is for additional trust from people who are accessing that web page. It doesn't mean the security of PayPal is better. It doesn't mean the HTTPS is better than Africana Institute HTTPS. No, it's the same thing, but the fact that this is PayPal and the fact that their certification authority took extra time to validate other things like physical buildings, and if there are a public company or a registered company, that gives people the trust, the additional trust that we're talking about here. So think of the PKI. All right, think of the PKI as a bunch of a certification authority that trust each other, and they now tell everybody you should be trusting this, you should be trusting this because we said we trust this. Okay, so PKI proves the identity of a public key holder. In another word, the certification authority tells everybody, yeah, you should trust this public key because I've signed it. Because I've verified the identity, I've signed it, and since you trust me, you should trust this person as well. And that public key, this public key, will be on that digital certificate. That digital certificate. Okay. So there are a bunch of certification authorities. Some of them are private and some of them are public. Yeah. So when you take a look at companies like GoDaddy, this is what we normally call a public digital certificate. Who's here have set up a website, or who's here have bought a domain from GoDaddy? Any domain builder here? No, just me?
You do.
Okay. So GoDaddy, if we go here, we go to the certificate here and try to validate their certificate, we can see who issued the certificate. It happens to be GoDaddy because they basically issue their own certificate. I'm looking at the wrong place here. Can y'all see this, or is it too small? Too small? Can you see it okay?
No, it's okay. It's okay.
Okay, perfect. So we can say, okay, so who issued this certificate? Well, again, this is that digital certificate that we're talking about. So who issued it? Well, in the case of GoDaddy, GoDaddy themselves did this GoDaddy Secure Certificate Authority. That's the CNAME, right? The common name that issued this certificate. We're going to talk about CNAME and SAN and things in a minute here. It was issued to who? To GoDaddy. Basically, they issue this to themselves. The validity of this. Basically, a lot of these you got to renew this every year, like once a year. Some of them are a couple of years, but they usually do once a year just in case if the key gets stolen. And then you have your hashing and things to make sure everything that comes from here is validated, it's original, and nobody have tampered with it. So if we go to the details of this, we should be able to see the public key that we're talking about. Here, subject, public key. This right here, I don't know if you can see it, that right there is the public key. The whole number right there. They're using the 2048. They're using the AES. In their case, they're using AES. The algorithm has to be RSA. There we go. I say AES, but I meant to say RSA. So they're using RSA as the algorithm. And the subject key, the public key, is this. What this means, probably GoDaddy wasn't a perfect example. Let me find a different website. Because GoDaddy issued themselves a certificate, so it's not a perfect example. But I wanted to show you, if you want to be trusted on the web, where can you go to get a certificate? If we go to Africana Institute, for example, we went to Cloudflare. So if I click on the certificate that we're using, because we have that HTTPS, we are using Cloudflare, I believe. And Cloudflare uses what they normally call something trust. It's a free certification authority that gives out a like free digital certificate, basically.
Is it
But
in trust? In trust?
I believe so.
Okay.
Yeah, I believe it's Entrust. If it's not, I have Let's Encrypt. There we go. No, Entrust is paid. Let's Encrypt is free. Let me bring it. Let's Encrypt up. Let's Encrypt is free. This is if you visit a bunch of these websites and you find them secure, you got to thank these guys. Uh, because GoDaddy and all these other certification authority, they were making a lot of money from this. But Let's Encrypt made it free. It's non-profit. It's funded by the Googles, the Amazons, and the like. And what companies do, they basically just integrate it with the Let's Encrypt, and then start offering secure digital certificate. So Let's Encrypt. Think of Let's Encrypt as a certification authority. They have it here. So certification authority that is free. It goes in, it helps encrypt the web. So one of the reasons why Let's Encrypt have become very common is because companies like Mozilla, Firefox, people who created Firefox, they came out and they said, you know what, from now on, we're not going to allow on a non-secure website to run. In other words, your website must have HTTPS if it's going to be loaded up on our browser. And that basically changed everything. They're basically trying to force everybody to be HTTPS. And they even recently introduced a protocol known as HTTPS over, I think over DNS, DOH, DNS over HTTPS, I believe. There you go. Yeah, DOH. DNS over HTTPS. And this is basically it's their attempt to say, look, every website must be secure. Remember, DNS is what does the www is the name. And right now they're saying, look, if you're gonna run any name on the web, it has to go through HTTPS. I will come back to this. It's very important. If you're going to be working in cybersecurity, there's a highly chance you're going to come across this. In fact, in cybersecurity, this is giving us a lot of problems. Because remember what I teach you from the beginning. Too much security is not security. And when we go in and encrypt everything, which is what this does, that means even the bad guys, even their trafficking, we are not able to see what's in it. And that's a problem for the defender. Because for you to secure anything, you got to be to open it up, take a look inside, and see if it's a bad traffic or not. Back to my point. So if we bring up one website, somebody give me a name of a website, any. Put that in the chat. No? CompTIA. All right, let's go to CompTIA. All right, there we go. All right, so CompTIA. Well, who CompTIA is trusting for their certificate? Well, we can click on the little lock. It used to be a lock. And then go to connection secure, bring up the certification authority. And we can see a few things. Actually, CompTIA, they're just like Africana Institute. They're using the free. They're using the Let's Encrypt. Can tell that already because that right there, the Google Trust Services. Google is behind the Let's Encrypt. They're the one that donated a lot of money. It's open source, it's free, but they're backing up the whole thing. But we can see that they have gotten their digital certificate from Let's Encrypt, right? And that digital certificate was issued to CompTIA. And when we take a look at the details of this, we can see that the version, which I'm going to be teaching you this, it's not, I'll get to it. The version of the certificate, it's important for you to know that because it's going to be on that exam. Not this for CompTIA, but the one I'm going to be teaching you here in a minute. The serial number specifically, the algorithm, all right? In this case, they're using ECDSA. It was issued by, there we go. You got the CNAME, you got the objective, you got the country, and it's valid from and after. Then you get to the key, the algorithm. They're using ECC, the elliptic curve cryptography. Interesting, right? They have the security. I taught you that last week. And they're using, this is the key. And as you can see, their key is smaller because they're using ECC, elliptic curve. And then there's a few extension. I will be talking about some of these, not all of them. But we're going to talk about things like SAN, subject alternative name. These are extensions of your security. Basically, let's say that you want to secure the CompTIA.com, but you also want to secure the subdomains. You want to secure certificate.comptia.com or .org in this case. Well, you're going to have to use some extensions, and I will be teaching you that in a minute. And then you have your hashing, your hashes, again, to make sure that the key is to make sure that everything we get from CompTIA.org, it's original, it have not been tampered with. That's really what that is. And obviously, they also have the certification and revocation list right there. Certificate and revocation list, just in case if their private key gets compromised, they can tell everybody, look, don't trust us. We have been compromised. The certificate have been revoked. Okay, if we go back here and try to bring all that back home, we can see that the PKI, the public key infrastructure, that's the infrastructure that brings everything together. In another word, it's a bunch of certification authority, like I mentioned. So there is two types of certification authority. There is the public, and what I just spent a few minutes talking about, the Let's Encrypt, the GoDaddy, the Entrust, according to Eugene. All of these are public certification authority. And they basically, once they sign something, once they give you that digital certificate and they sign it, that means everybody publicly can trust it because these are public CAs. But what if you're a company? You are a company and you want to offer cryptography. Don't lose the focus, guys. We're still talking about cryptography here. What if you're a company, you want people to authenticate on your door by swiping a badge? I'm sure some of you have experienced this. You swipe the badge, you get in. You don't have to do anything else. Everything looks like it's being taken care of. Well, you have to set up a private CA. A private CA is a certification authority that is trusted within a given organization, within that particular company. So you will set it up similar how GoDaddy set it up theirs. You will have a server that's giving out certificate that is signing the certificate and the like. But the only problem is that this private CA, anything that is assigned by your CA, it's only going to be trusted within your organization. So if anybody were to take that and try to search on the web, literally it's going to tell you this is not trusted. If you've ever used Google Chrome and then as soon as you try to open it up, is yelling at you, is telling you, hey, this is cannot be trusted. Well, that's because the CA that was giving out the certification, it was a private CA or it was untrusted. It was not public. Okay. All right. Let's keep going. So types of a certification authority issued by CA. So there are quite a few of them that you can get. One of them being a domain validated or DV. This is where they basically do the basic validation if you own the domain or not. Simple. It's where you go to GoDaddy. I came out of it early. If I go back to GoDaddy and show you their service here. Where is it? Websites. Digital certificate, where that would be. Or domains. Maybe I'll find it here. I am struggling when I should be Googling this. GoDaddy. Digital certificate. They sell this and it's yeah, there you go, SSL certificates. This is the service. So basically you go to them, you buy this, you say, hey, look, I want to be trusted on the web. I want to start, HTTPS. And you pay them some money, and they tell everybody this person should be trusted. Or this website in this case should be trusted. So that's regular. That's just a domain validated certification kind of a validation. Basically, they're going in, they're just validating if the domain is yours, if you actually own the domain. And then you have your organizational validation, where they validate your organization. And then you have the biggest of them all, and this is the extended validation. This is where you're not only given the HTTPS, but you're also, they're putting the name like that, like same way PayPal have it, like that in the browser. So that as soon as people see it, they're like, oh yeah, you are secure. Again, it's for trust purposes. It doesn't mean the security is more or less. Okay. All right, somebody say can hear me. Can you all hear me okay?
Yeah, we can hear you.
Yeah.
Yeah, we can hear you. Very clear, loud.
Okay.
Yeah.
So basically, I have a question.
Yeah.
It seems like there's some organizations, to my understanding, that became what I can call providers of those certificate of authority,
Yeah.
and say, okay, so now we're providers. So if you want us to give us digital certificate, we can do it. There's some companies that has that capability, or they actually become providers.
Yeah, GoDaddy have that capability. That's why I keep talking about. GoDaddy have that capability. But
Yeah.
for you to be able to do that publicly, you have to go to this I think CCAN. It's the nonprofit that deals with the DNS.
Okay.
Yeah. But if you want to do it privately, knock yourself out. Knock yourself. There are tools like SSH, you can use it to do this kind of stuff. So there are tools, even Microsoft, they have some things. If you play with Microsoft server, they have some built-in things that will allow you to set like a private certification authority. Did I answer your question? I can.
Yeah.
There.
Yes. Yes. Thank you.
All right. So let's keep going. So what is the importance of a certification authority? Well, that's the importance of them, as you probably can guess it. It's they tell everybody that, look, we can trust this person, right? They give you that HTTPS. They let the browser know, look, Mr. Browser, you can trust this person. Why? Well, because we say so, right? So the trust is established and secure communication is established with that S right there once everything it's there. So CAs are part of the PKI, are part of that infrastructure, and they trust each other. So a CA from one entity can be trusted by another CA from another entity. So in another word, think of that DMV analogy. If the DMV in Atlanta gave you the drive license, if I'm driving in California, the police pull me over, that police is going to trust my drive license because they trust the DMV in Atlanta. So that's the same concept here. If a website is being protected by GoDaddy and I visit that website and I'm from Africa, well, it will trust me because it trusts GoDaddy. Even if somebody from the US is visiting another website who happened to have gotten their certification from an African certification authority, vice versa. So it's all part of that PKI as well. So these certification authority have a hierarchy. just like DNS. I hope we will talk. We will have some sections where we dig a little bit deeper into DNS. There's a hierarchy to this. There's a root certification authority. These are that sort of like the self-assigned sort of like CA that I was talking about. We sometimes call those a root CA. So root CA are self-assigned, meaning this is the mama, right? This is the very first certification authority that everything this certification authority signs, it is. So on the web, what end up happening, you will have like a hierarchy where you will have a root CA, and then you will have intermediate CA, and then you have what we normally call a leaf CA. In other words, if you think about the DMV, I used to live in Alabama, and in Alabama, in a little city called Mobile, it's probably not that small, but Mobile. So in Mobile, we didn't have a DMV that can give us drive license. What end up happening, we will go to the local DMV, they will take all the credentials and everything, and then they will send that stuff to Birmingham, where there's actually an entity that can actually give us the drive license. The same thing apply here. What happened is we have a root CA that basically signs everything. And then this root CA also signs these intermediates. And then these intermediates signs this leaf certificate. Why they set it up this like this? For security reasons. Remember when we say segmentation? Yeah. So what end up happening is that if the leaf certification authority gets hacked, then it's just that portion and nothing else. And then what end up happening is that a root certification authority is always offline. They disconnect that thing always, unless there's something that needs to be added or something that needs to be updated. Otherwise, they keep this thing offline as well. So they let the leaf CA kind of do the signing. If we go to one of the pages here, till I find it. I'm going to go to Google. See if Google has it. If we go back to the certificate, let me show you this hierarchy that we are talking about. If we go to details here, yes, there we go. This is the hierarchy that we're talking about. If you see, Google has this google.com that which have gotten the certification authority. So think about this as the leaf CA. Because everything under Google with that right there, that star, it simply means, look, anybody behind google.com should be trusted, should be secured. So cloud.google.com is also secure. Store.google.com is also secure. That little star there, that's what that means. So think of that as the leaf CA. Then you have the W2E or the WR2. Think of this as the intermediate CA. And then the GTS root, think of that as the root CA. So that's the hierarchy. That's the hierarchy. The idea, again, is if Google gets hacked, everything that is protected by this or everything that has been signed by that intermediate doesn't mean it's hacked. Right? Because this intermediate right here can be used to basically sign the multiple leaf CAs, multiple certification authority. Okay, that's basically the big idea behind this. So back to this. So you have this hierarchy, but also you have those single CAs that can be issued directly to something. These can also be those self-assigned. Okay, and then obviously self-assigned, which you will find them in private companies. They're used locally for protecting themselves privately. Okay. And somebody raised their hand. Please go ahead.
Yes, I have a question. Can you hear me?
Yeah, I can.
I have a question regarding the slide on certificate hierarchy.
Yeah.
So if you could go back to that, I'll use it to ask my question, please.
Sure, I'm here. Is the slide or back to Google?
Back to Google.
There we go.
Thank
Here-
you. Yes, so assuming that WR2 is hacked,
Yep.
does it mean that asterisk.google.com is also hacked? And so therefore it needs to be, you need to get another certificate, or it's just the intermediate that is affected?
Yeah, actually, that's a great question. So WR2 is signing multiple certification. So Google happened to be one of them. Think maybe it has also Microsoft, for example. Maybe there's also Facebook here. So if WR2 gets hacked, all of these also gets hacked. It doesn't mean they lost anything, but what's going to end up happening is that WR2 is going to revoke that certificate that they used to sign the Google, basically telling everybody, hey, you should trust Google. So they're going to revoke that, and that's going to have some effect on Google and anybody else who has been basically trusted or assigned by WR2.
So to my follow-up questions, so it means that asterisk.google.com basically also gets affected and needs to be revoked.
It needs to be revoked. Yes, yes, and yes. Yep,
Thank you for the clarification. Thank you.
absolutely. Okay, back to this. So digital certificates. Well, these are used to prove the ownership. That's the key word, the ownership of a public key. I have shown you this multiple times, so we're just going to keep going now. So if you look at the digital certificate, like the one that we've seen from Google, there's the public key that is attached to it. And that public key basically tell everybody, look, if you're going to communicate with me securely, go ahead and send your things using my public key. I will be able to open it. I'll be able to decrypt it. Okay. So again, on the top of the digital certificate, you have things like the subject, which means the entity that's being secured, when it's valid from, and when it's going to expire. All of that information, it's from this, that's going to be on that exam. That's known as X.509. X.509 is the standard. If you're going to register to get a certificate, this is the standard you have to use. And it's known as public key infrastructure, or X.509. That's really what we normally call it. It's the common format for all certificate. You can name anybody who is acting as a certification authority. They all use the X.509. So how does that look like? Let me go ahead and show you this, because like I said, it's going to be on that exam. Oops, there we go. X.509. If we go to images here, bring up this quickly. There we go. Zoom in. There we go. Hoping you guys can see this. So there has been kind of a different variation of this or versions of this, but the X.509 goes in and give us the standard that we need when we're trying to register for a certificate. So again, it goes in and tells you the version. It's version 3. That's the version we're on right now. And what included on this? You got the serial number, you got the algorithm, issued name, validity, the subject, the actual entity that's being secured, the public key, issued ID, and those extensions that I mentioned, the SANS, the FQDA. We're going to talk about all that in a minute. Okay, but I want you to know that X.509 is the standard that is used when we're trying to register for a certificate. All certification authorities, CAs, they use this now. This is not something like you have to specify to them, look, I need to make sure you're using the X.509. They already know, right? They already know. And specifically, we're using this third version. Back to this. I'm hoping you're still following. Are you guys with me? Haven't lost anybody yet? This is a little bit dry topic, so you got to talk to me.
We here.
Okay, fantastic. All right, then you have your PKCS, the Public Key Cryptography Standard. is a group of standards. It goes from number 1, 3, 5, all the way to 12. This is one is used when we're implementing cryptography into software. Microsoft was a big champion of this because Microsoft and software is like it's really Microsoft. Software is in the name. So they basically pushed a lot of this, the PKCS. These are like the standards. If you're going to be designing an application and you want that application to be trusted, you are going to sign a certificate. You're going to sign your code, there we go, your application using one of these standards. If you have a Mac computer and then you try to install a program and your Mac computer is telling you, hey, we can't trust the developer of this thing. Well, that's because they didn't sign that code, that program you're trying to download. Or if you're a developer and you want that program to be trusted, you are going to use one of these standards. All right, what are some of the types of certification that the digital certificate or your digital drive license? Well, you have SSL/TLS. Who's you ever heard about SSL and TLS?
I know what SSL means, but I'm not sure what it does.
Not sure what it does. Welcome to the class. People say, I have. Okay. Well, SSL, this is what I said for last. What they did, guys, was this. When they designed the internet back in the days, and they designed the web in 1991, when the Lee guy, he works at the MIT, when he designed the www and come up with HTML and these other things, security wasn't a priority. Security was not on top of the mind. So what they saw was that we have developed this thing that works, but now we're going to have to try to secure it. And that's really where SSL and TLS comes in. So SSL and TLS are protocols that are used to secure other protocols. I want you to remember that. These are used to secure other protocols. For example, if you have a protocol or a port, let's say port numbers as well. But if you have a protocol that is not secure, such as HTTP, that's not secure, and you want to secure, guess who you're gonna go to secure it? SSL/TLS. This thing need to come off. SSL/TLS. This is what's going to provide the security behind the scene. This right here. So SSL, it's old. What they did, they developed SSL, and when they got to SSL version 3, this is the secure socket layer. Let me just be telling you what these are. Secure socket layer. So when they got to version 3, there was a vulnerability that's known as a Heartbleed vulnerability that they found. Google found this. That's why most people talk a lot of nonsense about Google. I have a lot of respect for Google. Google have done a lot for the web. A lot for the web. They even hired the people who created this thing. Like the guy who created the Java programming language works at Google. That tells you that these people are at the top. Anyway, SSL back in 2014, they found a vulnerability. A bunch of Google researcher. That vulnerability was so huge that vulnerability ended up having its own web page. It's known as a Heartbleed. This right here, which you can read up a little bit on it, but I will be teaching you a little more about this once we get there. Because there's the CVE number, meaning the vulnerability numbers and so on and so forth. But I want to dig a little bit deeper into this, if this website will come up. Sometimes it doesn't. There we go. There we go. Let me zoom in. So 2014, they found a weakness into what's known as OpenSSL. OpenSSL was the tool that they used for SSL. And they said, you know what? This is bad news because SSH, secure socket layer, is what is used to secure the web. For you to get HTTP with the S, that means you are running SSL slash TLS behind the scene. So basically, in another word, HTTP is not secure. When they developed HTTP, they were not thinking about security. But for you to be able to secure HTTP, you have to use SSL slash TLS. Okay. And then that's how you get that S right there like that. Okay. And this goes for all other protocols that you can think of. For example, let's say FTP, File Transfer Protocol. If you want to secure this, you can secure that with the TLS, and that's going to give you the FTPS, the FTP security at the end. LDAP. LDAP. There we go. You want to secure LDAP? Well, you run that under TLS, and it's going to be LDAP-S. Basically, any unsecure protocol, we use SSL slash TLS to secure them. Anyway, so why do we have the two of these? That was the reason why I came here. 2014, they found a vulnerability that's known as a Heartbleed. And they say, you know what? We are in big trouble because this thing is used to secure the entire web. And now there's a problem with this. So 2014, they have a CVE. This is the common vulnerability exposure. I will teach you what this is once we get to the vulnerability section of the class. But they said, you know what? After version 3 of TLS, they say, you know what? Let's go ahead and rebrand this basically. It's not necessarily that. If you read the books, it doesn't say they rebranded from SSL to TLS. But basically, they said we're going from secure socket layer to transport layer security. There's that. There we go. To transport layer security to the TLS. So they went from SSL version 3. They basically removed all the weaknesses, meaning the Heartbleed, these vulnerabilities. They removed all of that from SSL version 3, and they basically rebranded that to TLS version 1, 1.0. Right now we have 1.3, 1.3. And the TLS 1.3 is what came with the thing that I mentioned a minute ago, the DOH, the DNS over HTTPS. Right? DOH came with the version TLS version 1.3. I'm hoping you're still with me. Okay, and I'm hoping you got the idea of these two protocols because they secure the web. All right, back to this. Okay, so you can use that for securing the web. You can use the digital certificate to secure the web through TLS and SSL, and hopefully now you understand what those are. Also, you can use that for code signing. I mentioned that. If you're a developer, you can definitely use digital signature to sign your code. Email, absolutely, and your root certificate, absolutely as well. Emma, take it away. You have another question for me.
Yes, with regards to the SSL slash TLS certificate, does it matter which version of the TLS that is used or which, and we mentioned 1.0 and 1.0 and 0.1 and 0.3. Does it matter or which of the two is more secure?
Right. So obviously you can guess that. You can say 1.3 is more secure, and that would be right. But either version of a TLS is very secure. So it really doesn't matter which one you use. It's that the 1.3 is the one that have all the bells and whistles. So if you were to take a look at the cryptography, I like when you guys are asking me this because there's a lot to talk about here. If we take a look at the cryptography that came with the TLS version 1.3, TLS v 1.3 protocol. Yeah, let me say protocol. Let's see if I can find the actually cryptography behind it. They basically introduced a bunch of a great let me see. They use a different cipher. I think I will come back to it at some point in this class, hopefully. All right, well, let me not waste any time. Both of them are secured. It just the 1.3 has more kind of a cryptographic algorithms, better algorithms integrated into it. Good. Let's keep going. All right, so how would you implement that? Well, there's what they normally call a subject alternative name, or SAN, and there's also what we normally call a common name. SAN is going to be on that exam. Common name, it's fading, it's kind of going away because it's old. So what are these two? Well, these are the extensions. If you remember earlier when I was keep telling you, there's an extension to a certificate, an extension to a certificate. That's what these are. So SAN, it's an extension to the X.509. Remember, X.509 is the standard for this certification that basically allows user to specify additional host names. In other words, it allows us to use a single certificate to sign multiple host names, to sign multiple names. So if you have a google.com, that's great. But what if you have eat.google.com? How do you secure that? Well, if you use the old way of securing things using what we normally call a common name or FQDN, this is a fully qualified domain name. It might be on that exam. So fully qualified domain name. If you use this, you can only sign the entire name, the common name. You can only sign the whole host, the whole name. In another word, you can sign www.google.com, the entire thing. But over the years, they have been pushing the SAN. And guys, please put yourself on mute so we can have like a good record. So you can have you can have your entire domain and subdomain secured by using what we normally call a SAN. So a SAN, it's a way of securing not just your domain name, but also your subdomains. Common name was used to just secure your host, just secure the domain, and that's it. So it's going away. It's old. It was used in old, but it is still in many implementations. So and it's kind of like backward compatible with the SAN. But again, going away. This is coming up, and the biggest difference of these two that you need to remember is this guy right here, Wildcard. And this is going to be on that exam, the Wildcard. A Wildcard is a star. It's a little star. I showed you that when I was showing you Google. It's a little star that you see on under domain names, where they said there's a star, then there's google.com. That's really what the Wildcard is. What that means is that the certificate that we're using to secure google.com that same certificate can be used to secure multiple domains and subdomains, like multiple subdomains in this case. Just put it that way. So a fancy word for that is wired card. You see that on that exam because they will ask you that on that exam, and the wired card is going to be one of the answers as well. Okay. So SAN used to protect multiple domains. Keep going. Okay, so how would you go and get this? Well, there's what they normally call a CSR. CSR, the certificate signing request. This is the first thing you do. You're gonna have to remember that for your exam. The questions are gonna ask you, oh, you are a security analyst. You're trying to secure this thing. And then you are going to do it using cryptography. What is the first thing you do? You need to request a certificate signing request. That's like the first step you do is requesting this. So what is this? This is where you're going in, you're trying to get the registration going. So registration, identification, and authentication procedures. That's really what that is. A CSR is when you go and you generate a key pair, and then you send that public key to a certification authority, something like GoDaddy, with that certification signing request. Okay. Again, I'm not generating no key pair because I did show you all that last week. That's why I asked you guys to be here every day, right? Every time we meet, I ask you guys to come here. So I'm just going to talk about this. So you generate that key pair. They give you the public and private key. Then what you do, you share the public key to the certification authority, to the GoDaddies, to the Entrust, to one of these certification authority on the web. You keep your private key private. You don't share that with anybody. And that certification authority is going to perform that identity check to make sure that, hey, look, the key belongs to you, the domain is yours, and all that stuff. When they're done, they're going to sign that key, that public key. They're going to sign it and then put that on that certificate. Basically, give you that certificate that tells everybody, yeah, you can go ahead and trust this person or this website now. But the whole process of doing that is what we normally call a CSR, or certificate signing request. The CSR is encoded using this ANS.1. Basically, it's part of what they normally call a PAM format, and it's based on the base 64 encoding. In other words, it's the ASCII. The stuff that you saw last time I generated a key pair, those numbers that you can read, that's ASCII. And you can convert that into base 64 and send it out to people. Base 64 is a little bit easier to read as well. If that doesn't make any sense, hey, come on, take one of those hands-on labs that I have in the hands-on course, where we kind of dive a little bit deeper into this in practice. All right. So what happened when the certificate is no good? Let me see how I'm doing with the time. Tend to keep talking too much. So what happened when the certification is no good? You got to revoke it. You got to get rid of it. So how you do that? Well, there's one we don't call revocation. Well, revocation is permanent. Once certification has been revoked, it cannot be reinstated again. Unlike revocation, suspension is reversible. That's when, okay, we have suspicions about this particular certification, we're investigating, but we can maybe reuse it in the future. That's suspension. Revocation, it's when this certificate have been hacked, and therefore we should not trust this ever again. Then we revoke that. So there's two ways of us doing that, and you gotta remember this for your Security Plus exam. The first way is using what we normally call a certificate revocation list, CRL. This is different than a CSR, the certification signing request that we just finished talking about. So CRL, certificate revocation list, is a list of a revoked certificate or suspended certificate. Basically, it's a list of a certificate that are not good, that we should not be trusted. So every time you visit a web page, your browser goes in, checks this list. Every time. You go to africaninstitute.com, where the browser is going to start asking the certification authority, the entity that gave me that certificate, hey, is this certificate valid? Can I trust this certificate? And if the certificate is not trusted, you get a message that tells you, hey, we don't recognize the certification authority, or this thing has expired. Like, whatever reason that made that cert get revoked, you will get that response from here. But so the browser would to check. So what is the problem here? Well, the problem is companies like Google.com gets billions of requests a day. Billions of requests a day. So if they have a certification revocation list, imagine a billion requests pointing to that. Hey, is this valid? Is this valid? Is this valid? You are going to run into a DOS, denial of service attack. Basically, the server that is acting as a certification revocation list that is housing that, it's going to shut down. It can't handle all those requests. Guess what they did? They introduced OCSP. OCSP. You got to remember this for your exam. This is the online certificate status protocol. And what this is, it's going to check to see if a certificate, one time, it's going to check maybe this morning, it's going to check just one time if a certificate is valid or not. When it knows the status of that certificate, it's going to keep that on its stamp. There's like little stamping that takes place here. It's going to stamp that to that domain so that anybody else who is asking if that domain is valid or not, or any other person who's trying to access that domain, OCSP can respond in real time, can provide the status of that domain in real time without going back to the certificate revocation list, without basically keep checking to see, hey, is this valid, is this valid or not. Basically, OCSP is the fastest way of checking to see if a certificate is valid or not. You got to remember that for this exam. All right, questions? Have I confused you yet, or are you still with me? Because I'm going to keep going.
Oh, it's getting deeper. Someone needs to always keep an eye on this, come back and check again so you understand them very well. A lot of acronyms related. Once you mix them up, you fail the question.
Yeah, absolutely. Okay, let's keep going. So I said last week that, hey, look, having a certification is great, but really we don't care if people knows the algorithm that we're using. What we care about is, are we keeping the private key private? And that's what this is. So key management, it's all about making sure that key is protected. So there's the little key life cycle where we're generating the key, then we're storing the key. Then if the certificates gets stolen or gets hacked or whatever, gets expired, sometimes they expire and people forget to renew them. Whatever the reason, we're going to revoke that certificate. That's the life cycle, basically. Once that has been revoked, then the key is no good. It's no longer good. You have your decentralized key management, where each host or user account stores its own private key. That's like decentralized. It doesn't belong to just one entity. Then you have some key management systems where we can basically store the key in there. There's actually two of these, which I'm going to teach you these. There is the oh gosh, I'm running out of the acronyms, so I guess I'm getting a little bit tired. But there's two of them. I think we're gonna get to that section and I'll teach you this. But key management systems. So keys are generated and stored on a centralized server, like having a server that houses your keys. And then you have your key management interoperability protocol, KMIP. They could be used to accessing those the keys that are stored on that server. But oftentimes, companies don't do this unless they have set up their root CA, or they have set it up their self-assigned certificate. You don't tend to hold on to your own keys, let alone to hold on to that in a server. If you do, you hold these on to, I want to say it's KPM, key management, something like that. Okay, I could be wrong. There's another one. There's a chip there's attached to your motherboard that you can use to hold on to the keys. I'm running out of that name, but you can also buy a hardware that's a
It's
specialized
TPM,
TPM. Thank you.
Trusted Platform Model.
Exactly. Trusted platform module. Thank you. There we go. So you can hold on, you can have the TPM hold on to your keys, trusted platform module. Or you can buy an HSM. Now the acronyms are coming back to me. HSM, hardware security module. Right? So these are the kind of the two ways. If you want to store the key privately in your own place, that's one way. These are the two ways of doing it. The TPM is not removable because it is attached to your motherboard. HSM is removable because you can just, it's a hardware that you buy and you start using it. Okay. All right. Any questions so far? Let me pause here so TL can do his thing. But any questions for me?
What's HSM?
HSM, that's the hardware security module. Hardware security module. Let me show you how it looks like. It looks like a switch. Have you seen a switch before?
No.
All right. Going to share my screen again. TL, are we all set? Okay. There we go. This is the hardware security module here. So this is the hardware security module. Basically, you can buy this. It's a specialized hardware that specializes in encryption and decryption, basically holding on to your keys and be able to process the key faster. So the hardware that's in this thing is specifically designed to process cryptographic things. And then you have your TPM, Trusted Platform Module. Is a chip on your motherboard. Looks like this. Is attached to your motherboard. And most laptops have this. So whenever you go in and you do a full disk encryption, which I'm going to talk about here, when you go in, you turn on your BitLocker and you try to do full disk encryption, the keys are housed here. They're stored here. Fantastic. Let me finalize this, guys. And then you can have some kind of a cloud provider stores your keys. I won't trust them, but you can.
Where would you have the HSMs stored?
Actually,
Where do you normally have them?
we were going to talk about this right now. So you say, what would you have HSM stored?
Where would you have them? Where would you have them stored? The location, where?
Yeah. So they have a specialized software that comes with it that lets you generate those keys and things like that. So there's not like a specific chip in HSM where the keys are stored here. No, it's actually stored in the whole thing. The whole thing is specialized for storing keys. And then it has a proprietary software that's inside of the thing too.
So would they be alongside your
I think the
racks and all that
question
stuff?
is the HSM, is it going to be on premise of the company or is being
On-prem
it's
or
being
off-site?
yes
Okay, I
on
understand the question. Okay. Yeah, no, so you will put this on the rack of where you have all your other stuff, your firewalls,
Okay, network rack and all that.
network rack. Yeah. And you will just, okay, let's say that you're trying to do like a self-assigned certificate. Well, then you will need this because most of the servers and things, their hardware are not designed to do the encryption, decryption quickly enough, but this thing does.
Okay.
Okay.
So is there a way to manually or program this to just take care of every encryption that needs to be done, relieving the other hardwares or the other systems of that task?
That's exactly why would you buy this? Yes.
Oh, okay.
That's exactly what this is designed for. All right, let's keep going. Let's finalize. Key generation.
So when we do a full disk encryption,
Yep. Go ahead.
so when we do a full disk encryption,
Yep.
there is a key generated, right?
Yep.
For there is a key generated. Those keys are stored on the trusted platform model, TPM.
TPM, yes. In your laptop.
Just on the laptop.
On the laptop, yeah. Most desktops, they don't have TPM.
Okay.
Yeah, because I mean, why would you fully encrypt your desktop machine? You don't go anywhere with that thing. So by your laptop, if you work for the agencies like the FBI, you got to have full disk encryption. And the place you store your keys is in the TPM. All right, key generation. So what is the issue here? Well, key generation challenges. Entropy. Entropy is randomness. So as you're going in, you are going in and generating the key. You want to make sure you're using the algorithm that does it, that have like a full entropy. That's going in and generating the keys and make it as random as it can be. That's the beauty of cryptography. You're going to make sure things are unique. TPM, like I mentioned, is the hardware. Gotta remember that for exam that is used to store the key. So it's attached to the motherboard, sometimes to the CPU with the newer computer, but most of the time to the motherboard. It's not removable. That's the problem with the TPM. It's not removable. So if you lose your keys, you're done. I had a friend who said, I'm going to be super secure. And then he went into the BIOS. He was using a laptop. So he uses the UEFI. Who knows what that is? UFI. UEFI. All right. Well,
BIOS format.
this is the newer BIOS. Let me
Yeah.
bring this here. UEFI. This is the firmware, we call it. It's basically the program that runs your hardware in your computer. So we used to call this a BIO, and the BIO is the blue thing you're looking at here. But UEFI is the newest version of this. So this is the program that gets all your hardware ready before your computer can turn on, before your computer can boot up. So this friend of mine, he said, I'm going to be super secure. So he goes into the UEFI, he turn on the secure boot. Secure boot require you to generate the key pairs, the keys, the cryptographic keys. So he does that. He stores the key into the TPM. Oh, no, actually, he stores the key into a USB. In his case, it wasn't into a TPM, it was into a USB. So he put the keys into a USB, and guess what happened? He lost the USB. And guess what happened? He never used that computer again. Because the computer couldn't even boot up because of the keys. Anyway, so TPM, it's a hardware that is attached to the motherboard that cannot be removed. It's used for things like full disk encryption. Then you have your HSM. HSM is removable. That's the key. If on this exam, if they ask you, you want to do cryptographic things and which one of the following hardware that is removable? If they're talking about removable anything, it's that guy right here, HSM, the hardware security module, right? Removable. You can also set these up as virtual appliances these days because, they're trying to virtualize everything. And then you have your secure enclave. So secure enclave are kind of like a hardware-based security features that is designed to provide a secure environment. So basically, you see these into things like Apple Secure Enclave processors, which is sort of like integrated into their chip, their M1, and the chips that they've been putting out. Intel does have that as well. But again, these are like locations where they house the cryptographic things within those processors as well. What about if you don't want to do this? What if you want to give this to a third party? Well, that's where you have the key escrow. Key escrow is like your backup, right? Key can be backed up to a third party. So key escrow, here we are. Key escrow is by taking the key and give that to a third party, meaning another company that can basically, that is trusted, that you trust, where you said, look, if I ever need the key, I will come to you. Yes, perfect. So now there's a key escrow. On that exam, if they ask you, oh, the company's trying to store the key, but they give the key to somebody else, to another company, they're talking about key escrow. Eugene, do you have a question for me? Go ahead.
Yes, I understand the TPM on the laptop and
Yep.
how that works and secure, but the enclave, isn't that actually the same thing?
Technically, but most of the time, that's within the actually CPU, the
Oh, it's in the
newer,
P. Okay, got it.
the newer CPU.
Got it. Got it. Got it. Okay.
EPM is mostly on the motherboard.
Okay, makes sense. Makes sense. Second question, Professor.
Yep.
When we talk about placing the keys in the virtual, I mean, if something happened to that machine, then your keys is gone too, correct?
That's right.
So is that really safe and secure?
That's a good question. It really depends on how the infrastructure is set up. Uh, but if you have all of that in the same location, yes, you do have that single point of failure. If it dies, everything dies. But most of people who are doing this like seriously, they're going to try to what's that word I'm looking for?
Redundancy?
Segment and
Oh,
redundancy.
segment. Okay, all right.
Yeah.
Okay.
That's where you will buy the HSM and these other things to try to
Got
separate
it.
tasks. Yeah.
Thank you.
All right. So keys can backed up to protect against data loss. Exactly. Anyone with access to the backup keys can impersonate you. What does impersonation means?
Pretend to be you.
Exactly. Pretending to be someone that you're not. So that's the problem I have with key escrow, basically putting too much trust into a company. But they do that. Another thing that we can't
Related to social
do.
impersonation.
Shukri, please go ahead.
Yeah, this is related to the social engineering.
Yes, it is.
Impersonation.
Yes, it is. Another thing that we can do with the key is know what they normally call the M of N control. Who is here have heard about that? Give me those yes in the chat. Who's ever heard about an M of N control? No. Yeah, this might not be on that exam. So the two-man rule of nuclear launch authorization, basically what the M of N control does, we're taking the key, then we're splitting the key or portions of the key in between multiple people. So it's a cryptographic method that's used to ensure that critical actions like launching a nuclear bomb or launching a nuclear, that type of function, it's carried out by multiple people. In other words, multiple people have to be present before that actually action takes place. Why they do this M of N control? Again, it's for enhancing security. In other words, not to put too much power into one person. Like, for example, in the US with the nuclear, President Biden can just push a button. Right, there's multiple people that have to be present and they turn the key at the same time. They did all that so that multiple people have to agree on that particular action. So the other thing is that whenever you have an M of N control, let's say you have 5 people, and out of those 5 people, you just take 3. You say, unless you 3 are here, this is not going to work. So you 3 knows the key, and all you 3 have to be present. So the beauty of that, it's good for key recovery as well. In other words, if one person doesn't make it or doesn't show up, well, the other people knows the key. We can still carry out the function. Oh, the only company that does this are the company that really they're dealing with the super secure stuff. Okay. So the idea is to split the keys between multiple people so that not single person can carry out any given tasks. Multiple people have to be present for that given task to work. Keep going. So disk and file encryption. So this stuff in the real world. So disk and file encryption are crucial when it comes to cybersecurity. You know that already. We want to encrypt data at rest or data in transit or data in motion. But disk encryption and file encryption is when we're encrypting data at rest, meaning data that is stored in your hardware, in your hard drive, and taking a nap. So what we end up doing, we do things like full disk encryption. Full disk encryption is when you encrypt your entire hard drive, or you can also do portion encryption. We're encrypting like a partition of your hard drive. Think of your employee's laptop. A lot of laptops are the ones that does this, the full disk encryption. You also have self-encrypting drive, which is like basically a hard drive that encrypts things automatically. That doesn't require you to go in and turn on your BitLocker or use some kind of other software to do the encryption. And self-encrypting drives are more expensive because again, everything that you store in them, it's encrypted automatically. If you own an iPhone does that automatically for you. It does have that self-encrypting taking place in there as well. We can also do file encryption. That's when we're encrypting files. Everybody knows what that is. I think somebody raised their hand. Do you have a question for me? And no. Okay. Database encryption. Well, again, as we're going in providing security, we're doing security not only on hard drives and things, we also have databases. Databases, it's where we stored our things. You have SQL, SQL databases, SQL. You have a structured databases and you have unstructured databases, things like Microsoft Excel. But you also have MySQL database, and you have a Google big, I think they call big IP or big Q, something like that database. You have Oracle databases. All of these things are used to store data, and therefore they need to be protected. So within the database, you have tables, columns, rows, and things, and all those things have to be encrypted. And there's ways of us going in and providing encryption for that. We are going to talk about the threat to databases, things like SQL injection. We're going to talk about all of that once we get there, once we talk about application security. But here I want you to know that when it comes to database encryption, we're going in over securing that database that have those data in. It could be names, social security numbers, whatever data we have in that database, we're going in over securing that. What are some of the types of databases? Well, you have the transport data encryption, you have your column level encryption, you have row level encryption, your application level encryption. Again, unless you work with the databases, this is really not that biggie. But again, this is the type of encryption that we will do or we can do on databases. Best practices when it comes to securing databases, well, you have to identify which one is the sensitive data. You can't just be encrypting everything. Remember, encryption takes computing power. That's why we have those databases that we were talking about, those I would say database, but those hardware that I just finished talking about. It requires a lot of processing power. So therefore, we need to make sure we specifically identify what is important to us, which one is critical to us, and then decide how we're going to secure it. I think I started my lecture on that. The first day of class, I told you, you can only do the security of knowing your data. What does the company care about the most? And then everything you do, you apply, you do that from that perspective. All right. Database security, then we talk about transport security. Well, transport encryption and key exchange. We talked about some of these already. So transport encryption, it's when we secure data as it moves from point A to point B. Whenever you're accessing a website on the web, you are doing the transportation type of a things, where you are requesting a web page from a web server to come to you. For that to happen, we're using HTTP. What port associated with HTTP? I'm going to start asking you guys that so you can start memorizing this. What port associated with HTTP? Somebody said 80.
80.
80.
Thank you. What about HTTPS? Talk to me.
443.
443. Love it. So what about FTP? What port associated with FTP?
20.
20. Love it. What about FTPS?
Is that 21?
I like how you said 20 and then you said 21. 21 and 20 both are for FTP, the unsecure version of it.
Okay.
That's what I agree when you said 20, but mostly 21 is what FTP is known for.
Gotcha.
What about FTPS?
I don't know what S is.
No, yeah, it's not popular. I think it's like what 9 something, 989, something like that. Maybe somebody can Google this for us. But anyway, the protocol that you need to remember for that exam and the port that you need to remember for that exam, I will mention those. And trust me, FTPS is not one of them. The only thing that I said that is because every time we're taking an unsecure protocol and try to secure it using TLS, we just finished talking about TLS, TLS, which is what is happening here, the protocol will change. That's why we go from 80 to 443. That's why we're going from 21 to 989, if I'm not wrong. The protocol does change. But again, we're trying to secure things in the transport as they move from point A to point B. As you're going in and providing the security of this, or you're trying to do the securing from point A to point B, you have to exchange the keys. And I think somebody was asking this, like, okay, well, are we going to talk about key exchange? Yes, we are. And here we are. So key exchange is the process of which two parties securely established a shared secret key. In another word, key exchange happen with asymmetrical encryption. If you remember last time when we were here, we talked about asymmetrical and symmetrical encryption. And we said asymmetrical encryption, you have two keys, public and private. But we said that with asymmetrical encryption, there's a few issues with this. One, it's slow. Second, it's used for small files. And third, you got these certification authorities, the stuff we just finished talking about. You got the CA in between that you have to exchange keys and things like that. So what we end up doing, we do key exchange from the beginning so that we can use asymmetrical encryption to deliver symmetric encryption. I'm hoping that makes sense. If it doesn't make sense, stay with me. So what do we use for that key exchange? Diffie-Hellman. Diffie-Hellman is a protocol. It was the name of a person, but it's a protocol that we use for key exchange. Whenever your browser is trying to communicate with the web server, this is what they establish first. Like, hey, we're going to talk. I got your I got your asymmetrical public key. Let's start communicating. And they establish that conversation, and the browser basically says, okay, I am going to generate a symmetrical key, then I'm going to send that to you through Diffie-Hellman. Yeah, Diffie-Hellman key exchange. So Diffie-Hellman, it's one RSA key exchange. It's what happened with as a part of the Diffie-Hellman. But you also have elliptic curve cryptography. That also do have Diffie-Hellman for the key exchange. So that's how basically this is what is used when we're going in and try to exchange the symmetrical keys. Okay. I think somebody had a question for me. Questions? Because I'm finalizing, guys, and then we're going to go over the questions and then we're done.
Yes, I did. I had a question.
Go for it.
Port 80 is
Yep.
unsecure port.
You
So
said-
port 80 is unsecure port, right?
Yes.
So under what circumstance would you use that one instead of the secure one, 443?
Great question. Well, port 80, it's not heavily used now, but it was in the past before security become a big problem. I mean, becomes something that is a must-have. Now, to answer your question, you can use HTTP for testing and debugging things because everything that is within HTTP is naked. Like you can open it up and see what's taking place and what they're communicating and what's the traffic looks like. So we will use that for that purpose. Another thing specifically in cybersecurity, Emma, this is a great question. We don't always want HTTPS. Because HTTPS, it's secure, we ourselves can't really know what's going on. So in some environment, what they might have is a proxy. Who's you have heard about a proxy? Like a proxy server. No? Yeah, well, I will teach you that. A proxy, it's something that stands between two things communicating. So as the traffic is going from point A, going to point B, it goes to the proxy first. And then the proxy do what it have to do, and then send it to computer B. So to answer your question, Emma, when the traffic from computer A coming to the proxy, it's secure, meaning it's HTTPS. Once again to the proxy is going to open that up. Basically change the HTTPS to HTTP. The reason why we want the proxy to do that for us is security reasons. We want to be able to see what is inside of that traffic. Does that make sense? Does that answer your question?
Yes, it does. It does.
Perfect. Yeah, then you have your PFS. I think somebody was asking us, okay, well, if we exchange the keys and that session stays open for a long time, then what happens? Well, guess what? They introduced PFS, perfect forward secrecy. Perfect forward secrecy is literally a fancy way of saying that keys are going to keep changing. Keys are going to keep changing automatically as you establish different sessions within that thing you're communicating with. Again, PFS was introduced with the TLS version 1.3. It has always been around. It's a standalone protocol, the PFS. But now it has been added to this. So now, as you're communicating to your web servers, if they're supporting PFS as a part of that TLS version 1.3, the key can keep changing. So they're going in there using unique ephemeral keys for each session. So as you're accessing the bank and then you're accessing your money and then it says, I have $100, and 5 minutes later, you're doing something completely different. Well, the key keeps exchanging. The idea is to protect against man in the middle. Now, man in the middle. They used to call this man in the middle. They call it something else now. They're trying to change the man because some people say it could be a woman. And I think it's a something somebody can look it up. I'm running out of it. All right, so we're solving the problem of a key distribution for symmetrical keys as a part of the key exchange, the Diffie-Hellman. And we're enabling secure communication of untrusted network, obviously. That's what HTTPS is used for, so that we can communicate over the internet securely. And then we forms the HTTPS, the transport encryption, forms the basic encryption for many protocols, a lot of them, all of them. Keep going. Salting and key stretching. So salting, it's a method of enhancing the key. More likely, the key that is stored. It's a method of enhancing the hash. There we go. That's what I'm looking for. The hash. And if I haven't told you this, but hashing is used for integrity purposes, but we can use a hash to, I say hash, I don't know why, but we can use a hash to store passwords. When passwords are stored in your computer, they are stored as a hash. There we go, TL. You got it. On the path attack. There we go. Thank you. So when your passwords are stored in your computer, they're stored as hashes. Let me see what time I got. Maybe I can show you this. No, I cannot. I'm running out of time. But when it's stored in your computer, it's stored as hashes. And salting, it's a way to make that super secure. The reason of that, okay, let me kind of reverse this a little bit. Let me talk about this in a way where you can understand it. Salting, it's a way of generating a random value, a random number, and then add that number to the hash or to the password, if you will, before you store the password in your computer. So, in another word, once you added the salt, you guys remember the guy that used to do salt? What's his name? Salt Bay, the guy that used to put a lot of salt on the these famous people.
Yes.
I want you to think of that guy every time you see salting, right? It's like literally putting salt on a password before we hash it or before we stored it in the storage in your computer. So why would you do that? Well, that's because it's going to make it very more complex because you're adding additional number to it. It's going to make it more random. The reason why you want to do that, it's because rainbow table attack. There is this attack that is known as a pass the hash attack. Actually, you know what? Let me go ahead and show you this. Let me go ahead and show you this. So your password are stored as a hash. Does everybody know that, right? Your password are stored as a hash in your machines, correct? That's a good meme. That's a good meme. Right. So let's go to CrocStation and see a few things. So your password is stored as a hash. Let's say that your password is what? If you're to Google here, the most common passwords. What are the most common passwords? 1, 2, 3, 4, 5. Admit. You'll be surprised. People use the word password as password. Yeah. It's like millions of people. You might like, you know what? No, I don't do that. Yeah. Millions of people do that. So what this means is that if the attacker have hacked a company, which most companies have been hacked, and they have an access to your hash, guess what? You are not secure. Because they can definitely then go ahead and do what they normally could have passed the hash, meaning they don't need to know your password. They can easily get into your system without knowing what your password is by just knowing your hash, which they have stolen from all the data breach. Before I talk about this, let me show you this. We have one-on-one coming up. Okay, let's go to have I been found? Everybody, you should do this to your email. So let me put in my old email here, gmail.com. Basically, all of our email have been hacked. So if you go, have I been pwned? It's a database of a real attack, real data breach that have taken place in the past. Maybe TL can, be dropping these things in the Zoom for us or what you call Discord for us. But you go here, you type in your email, and then you can see that, for example, my old email have been pwned 16 times, meaning have been in the 16 data breaches. To tell you, your emails are not safe. If you use LinkedIn, LinkedIn have been hacked. If you're using Adobe, Adobe have been hacked. If you use Social Security database, the Social Security database have been hacked. So there's a highly chance that the attacker do have access to your hash. When they hack your computers, they steal those databases. So meaning the database of your Social Security have been hacked. So if your password is one of these very common words here, let's go and generate a hash for that. So let me go ahead and do MD5 hash generation. We did this last time. So let's go ahead and generate a hash. I'm going to create a super secure password, a capital P, the word password, and 1 at the end. I'm using uppercase, I'm using numbers, super secure. So I generate a hash, and this is the MD5 hash for it. And let me grab that hash, meaning I don't know what your password was. I have no idea that you're using the word password with 1 at the end as the password. I happen to get my hands on the hash. If I grab that and go to places like CrocStation, which is a free database that have billions of entry lookup. If you scroll down here, you'll see 19 gigabytes of billion entry lookup. That's a lot. If I bring back the hash here, let me paste that in here. And I don't know what your password is. If I crack the hash, and voila, it takes no time to come back and say, okay, so this hash, it's using MD5 as the algorithm, and that's the result. That's the password. And guess what? CrocStation have passwords for not only MD5, which is MD5. This is just to show you an example. It has some for LAN Manager, which is used by Microsoft, and TLM. Literally, like a new technology line manager from Microsoft, which is all your passwords in your Windows machine, they're stored as NTLM. Unless you're running like the latest version, which using Kerberos and some other cool stuff. But really, NTLM, which is weak, especially NTLM version 1. I will teach you NTLM in more depth in later section, so just keep coming. I took you there to tell you that adding a salt to that password, it will make it more secured for things like a rainbow table attack, which is where we know we have a hash, we have a hashing table, we have a table of hashes, of known hashes, and then we're going in and we're doing like things like brute force attack against that. We can also do things like dictionary attack, where we grab a dictionary and then we compare that with the hashes that we have. Easy stuff to do, as I just showed you on the crack station. What's the solution? Salting. Add a salt so we can make that hash random, completely random. So we can prevent from a pre-computed hashes table, rainbow table tables. Key is stretching. It's when we're doing a round of encryption. If you remember last time I talked about DES, then I said there was a 3 DES where you go and you encrypt, then you encrypt again, then you encrypt again. It's known as a key stretching. Now you're encrypting already encrypted things. So bicrypt, maybe somebody can put that in the chat. Bicrypt is one of the algorithm that does that on the web as well. Blockchain. Well, blockchain is it's a technology that is known as a decentralized. It's a decentralized database. Decentralized database. What does decentralized means? Let me ask you this. What does decentralized mean? I'm finishing up, guys. So if
Decentralized is having different data, having a database in different locations, not in one place.
not in a single, it's not in a data center. It's not housed in some
Yes.
kind of house somewhere. Thank you. So decentralized is when we distribute something between multiple, let's say multiple computers, multiple databases, as this gentleman had just pointed out for us. So that's really what blockchain is. It's a chain of blocks, literally. Chain of blocks that basically builds on top of each other. So it's a database that's different from what we're used to and is used to store and manage data. This is at the core of what cryptocurrency is. Without blockchain, there is no cryptocurrency as we know it. Cryptocurrency is the first application to use blockchain technology. But blockchain is this type of a database that is decentralized, meaning it doesn't belong to anybody. Right? Sooner or later, the internet it will be owned by the Googles and the Amazons, literally. This one time, Amazon was down, and basically almost the internet was down. When I say Amazon, I'm talking about the AWS, the Amazon Web Services, because all these companies they use them. So blockchain is that coming in and saying, no. Let's put power back into a bunch of people, so that not a single company have basically, let me just say, too much control. Anyway, so you have a distributed ledger. No single entity has control over the entire network. Absolutely. Then you have your blocks. Each block contains a collection of data. In the case of a Bitcoin, it will be a transaction data. And there's that chain of block. That chain is going to be hashed to prove to us this is original, have not been tampered with. Basically, whenever you spend your money, your Bitcoin money, there is, if I have 10 Bitcoin, BCT, for example, then I send Eugene 5 Bitcoin. That means there was a block with my 10 Bitcoin. And then I just give Eugene 5. So there's another block that gets created for that transaction. This new block is going to tell me I have 5 left, and then I have sent 5 to Eugene. And that information is going to be hashed. Oh, yeah. It's going to be hashed to prove to everybody this is original. Nobody have tampered with this. So there's the consensus mechanism known as a proof of work and proof of stake, basically to prove to people, This is original. There's also the immunity. That's why people of blockchain, meaning once something is added to the block, it cannot be changed, it cannot be tempered. It doesn't matter if you're a government or if you are whoever you think you are. There's that transparency because all the transactions are available online. You can see them. You won't be able to see how much I send it to Eugene, but you're going to be able to see that I send some money to somebody. That's the beauty. Now, without being too complex with this, look, blockchain is used with money, specifically internet money, Bitcoin, Ethereum, Solana, all of these things. But from cybersecurity perspective, blockchain can be used for voting. Actually, that's what might be on that exam. They might ask you, oh, what is the technology that's really good for voting? Blockchain. The reason is when you vote, once you vote, it's hashed, there's the integrity. You can't really, that cannot be changed. You can't go back and be like, I didn't vote, none of that. So blockchain, in a sense, it's a really good technology for voting, for the fact that when something is done, it cannot be undone. It can only be done one time. Remember that for your exam. Let me finalize this. Obfuscation. Obfuscation is making something difficult to understand. Most of the time, obfuscation is done with coding. People who do programming, they're the one that obfuscate the code. Some people who design malware, malicious software, they tend to obfuscate the malware, meaning when you're reading the code, you won't be able to understand what the code does. They make it hard for you to understand the code. Okay, that's really what obfuscation means. Steganography, it's a form of obfuscation. It's when we're hiding messages in other things. Your question is, what other things? Well, images, music, videos. So you can take a bunch of a social security number and then embed the social security numbers into music, into images, and then send that image to whoever you want to send that image to. And guess what? There is almost no technology that will be able to detect that. Because when you look at this. This is a regular image, and this is an image with with confidential information inside. Can you tell the difference with the naked eyes? No, you cannot. One of the technologies that we can use, though, to be able to tell this is known as a DLP, data loss prevention. I'll teach you this. DLP can take a look at the image size and then be able to tell, hold on a minute. And an image is supposed to be 5 megabyte. How come this image is a gig? Right? That's too big. So therefore, kind of raising the alarm to get somebody to take a look at this. There was this guy who was spying on the behalf of the Chinese government. He was working in the U.S. government, but he was spying. He was communicating with the Chinese government through steganography. He was there for 20 years. 20 years. Sending secrets, and they didn't detect him. Why? Because whenever they see the conversation, it was just like an image that he was sending. Just the image going to some location somewhere. So therefore, to tell you guys, look, not every image you see on the web should be trusted. Some of those images included the hidden information within them. I'm just kidding. All right, it's obfuscation. We're trying to hide things in plain sight, again, making something difficult to understand. Data masking, it's another thing. This is one is used to hide sensitive data, things like PHI and PII. You probably will see these on the exam. Data masking, tokenization, and the de-identification might be on that exam. So let's talk about this. Data masking, it's basically masking the data. More likely the real data, the confidential data. Many times this is used for training purposes, where you take like social security number. Maybe you want to train people on how to type social security number. Well, you take that, you mask it. Basically, you generate another one that is like a fake data, basically. fake data, but that do look like social security number, but that cannot be associated with anybody. Data masking, right? We're trying to hide sensitive information. It's done in a PII. This is protected healthcare protected information. This is your driver's license. Anything that identify you, it's PII. Anything that is your medical record and related, it's PHI. You don't know what those are? I'll be teaching you though in more depth later. Keep coming. Tokenization. This is all about substituting. So it's when we're substituting confidential information with the token. So we're substituting a data with the token. The beauty of this, it's reversible. But the only way you reverse this is if you have access to the actual thing that generated the token in the first place. So tokenization it's nice and it's being used in many places. For example, have you guys heard about Apple Pay? You guys have heard about Apple Pay, Google Pay, right? So what you do, you attach your credit card into the Apple Pay, Google Pay, and then every time you go to make payments, you just show your phone and the money gets, transacted that way. What is taking place? The app that has your credit card generates a token and sends that token to the register. Simple as that. And that token is going to have the money that get being charged and things like that. But it never shared your actual credit card with the register. That's the beauty. The credit card stays within your phone. Only the token gets sent to the register for that transaction. Can that be reversed? Yes, it can. But they will need to have access to your phone and things for this to actually be reversed. The identification, it's when once something have been obfuscated, for example, or tokenized or anonymized, that's the keyword I'm looking for. Once something have been anonymized, de-identification is the process of bringing that back to life, right? Bring back where we can understand it. It's like de-encryption in a sense. Okay, all this stuff is great. Let's take a look at a quick case study. I won't spend too much time on this. Stuxnet, if you haven't heard about this, I want you to watch the documentary about this. Stuxnet, it was an attack that happened on Iran nuclear program. They said that this attack was carried out by the US and the Israeli intelligence. Don't ask me the details. But anyway, this back in 2010 going to 2011-ish. So this attack was very, very critical in a sense. This was the first time that they use a cyber tool, a tool that is designed for ones and zeros, for code, to be able to destroy physical buildings, basically to destroy physical things, to get out of the cyberspace and be able to impact the physical world. So very, very sophisticated. It took a team of super smart people that was working at Kaspersky, I believe, 3 years. 3 years to decode this worm, to basically figure out, okay, what exactly does this thing does? So again, why did I include this here? It's because it used a lot of what we talked about. They stole a bunch of the keys from Microsoft. It was using 0 days. And they found out the 0 days, some vulnerabilities that were unknown into the computers. And they basically put that in a USB, and that's the story. That's how the story goes. Somebody picked up the USB and then inserted into one of the computers at the Iranian nuclear facility, and then kaboom, everything went haywire. This Stuxnet worm it became like the grandfather, because a lot of countries saw that and they're like, so that's how the game is played now, US? That's how the game is played. So they start developing their own capabilities. In fact, they copy the code and started using it. So over the years, there has been a lot of different Stuxnets variations. And these can be used to shut down power grids. They're used to shut down like physical critical infrastructure, I wanted to say. So I'm probably not a really good person to talk about this. What I want you to do as a part of your homework is to watch this documentary. It's a movie that's known as a 0 day. 0 day. And maybe TL can grab that in the, oh, he already did it. I like you, TL. Thank you. So you watch that so you can understand how there's a bunch of people from the NSA and these other places. They talk about how the whole thing was and the like. You are going to hear a lot of the terminologies, some of which we're talking about here, and it's a pretty good documentary. I like it, so that's why I'm recommending it. Anyway, that's the end. If you have any questions for me, please speak up now. If not, we're going to start with the questions.
I have a quick question.
Yeah, go ahead.
So if your email is it's not
Lori, can you speak up? I can barely hear you.
oh 1 moment.
Sure.
Is this better?
Yeah, it's great.
Okay. If your email address is on that website, have I been pawned? It's not enough to just change the password. You should really shut down the email address.
Well, changing the password should be more than enough. Just make sure the password is super secure.
Okay, thank you.
Oh yeah. Or take one step further and start using what is it, TL? My mind reading AI.
MFA. MFA.
No, not just MFA.
Bitwarden.
Bitwarden.
Okay.
Yeah. Start using Bitwarden where you don't have to keep remembering those passwords. You can just have that thing generate a super secure password for you. That's like the best. It's using like a key generator.
Thank you.
Absolutely. All right, guys, let me check your understanding, then I'll let you go. I see some people drop in here. Let me see. Did I went off? I sure did. 15 a minute. Oh my God. All right, questions. Read and let us know. What do you think? Talk to me.
Encryption.
The encryption. And that would be true. Good job. Did anybody pick a different answer? I'm looking at the chat here. Let me see.
I'm almost done, so wait for me.
Okay. Yeah, no different answers. Good. All right. Encryption it is. It's definitely not hashing. It's not tokenization. You're not, tokenizing things, and it's not segmentation. So encryption. Next question. We're saying D. Looking at the chat. Oh, Eugene, you dropping off? I think he did. And D it is. Good job, you guys. You guys were paying attention. That's good. Next question. Somebody say something? Please speak up. All right, people saying C, 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 C. Yep. Full disk encryption. Wow. Next question.
A.
That's a lot of A's.
And
I got people saying B. Anybody say B? No, A's. Okay. All right. Yep, yep. Symmetric encryption, one key. And that will be it. Fantastic, fantastic. All right, guys, I'm gonna run through resources one more time. I feel like it's been a minute since I talked about the resources. Let me go to Africana Institute here for you. So, guys, look, the recording of these lessons, if this thing can get out of my way, there we go. Well, better. The recordings of these lessons, if you come here to the website africanainstitute.com and go to courses, it should be the second one that says free CompTIA, live study. You click on that and you scroll down, you just sign up. The system is not perfect, but it works. You go here, you put in your name, just remember your email and your password so you can always come back and sign in. So once you finish with this, you sign up, you should have access to the recordings. And next time you come here, you just need to click on sign in. And then you sign in, you should have access to the recordings. Okay, that's one. Another one I want to mention, that we do have the all access. We have quite a few courses, including what you see here, and I'm always building some more. So it's a membership, that $29 a month, and then it gets you access to a couple of things, including some courses, but you also get practicing questions and performance-based questions, and I think you also get like 10% of whatever else you want from the platform that's not included within the monthly subscription. Live training. I do have some live training. In fact, there's one coming up in January 6th. For those who want to start a new year with me, hearing this voice again. January 6th is when I am gonna run another Security Plus. In fact, Security Plus, it's gonna run from 6 to 9 p.m. We do these are night classes for just 2 weeks. Just 2 weeks from 6 to 9. And this comes with labs access. You get access to your labs. You also get access to the complete course, the Complete Security Plus course that you'll find online as well. You also get access to the mentorship where we do one-on-one during the training, even after the training. That's where you get a fully access to me. I keep these classes small because, again, I'm doing this for the community. There's a few other courses coming up. So there's the CISA Plus that's coming up in March. There's a Network Plus coming up in February. There's another Security Plus again in March. And then if you're on the CISSP, I think I will do that sometime in April. Yeah, there we go. The CISSP as well. So I just want to share these resources with you. One last thing, the vouchers for those who are taking the exams. We are a CompTIA academic partner. Yeah, that's what they call us. So therefore, we get a discounted vouchers. So those vouchers, we want to pass those on to you. So if you want a voucher, any CompTIA voucher, grab it from here if you don't have one. This is gonna save you about like $100 or more. Because on the CompTIA, the same vouchers are like in 400s and 300s and things like that. But again, we want to pass those savings on to you since we get those. If you want to access labs, the CompTIA lab environment, again, we get these at the discounted, and then we pop those discounted for you. This is, I think, it's like $202 at CompTIA, but you get it here for $99. We send you the lab access key, and then you get a 12 months access to the lab environment. And that could be for Security Plus, CISA Plus, you name it. that. I do recommend it, especially for the people who are just getting started. I do recommend these labs. Highly recommend them. What else do I have here? Practicing questions. If you say, you know what, I don't need the training, this free training is enough. I just want to do some practicing questions. Hey, come here, grab one of these. And then you have all the practicing questions and all the PBQs, the performance-based questions as well. Okay, I want to say that so that you know that. And if you know anybody who's interested in some of those resources, please send them our way, okay? Okay, do you teach GRC? I do not at the moment. I do not. But I do have one-on-ones. These one-on-ones. If you just want me to mentor you, I've recently been having a lot of you coming on these one-on-ones, so I highly appreciate that. Actually, some people I find them really, really helpful because you get the help you need based on your needs. It's now within everybody. So 1 hour, I think we do anything they basically want. So if you sign up for this, you get an email with the questions. Those questions are to help me understand you a little bit better. So my ask you fill out all those, you send those back to me, and then I reach back to you. We schedule some time that works for the both of us. We jump on a one-on-one. So if you have questions on the GRC, you just want to know, okay, which resources should I use for GRC, or, critique my resume, or let's run it through this lab together. Grab this one-on-one. Last week you mentioned about 5 years for the PCI. What's that time for GRC? Yeah, so PCI is part of the GRC. It's part of the GRC as well. So there is a video that I put out on YouTube and social media that talks about the, PCI specifically, because it's a career if you're specialized in, you will get ahead. And it's not going anywhere. It talks about credit card, and everybody relies on credit card in terms of companies. All right. Any questions? I'm looking at those from the chat. Does cybersecurity take care of removing personal information from the dark web? No, that's something that you do by yourself. I don't know what you meant when you say cybersecurity takes care of that. Basically, the knowledge you gain from studying cybersecurity helps you not to keep exposing yourself. The other thing, there are some services from, for example, these not government agencies, these credit card vendors. Equifax got breached, but there is this Equifax competition. There's this company that does this really, really good that I like. Let me see if I found them. I'm forgetting their name. There you go, Experian. There we go, Experian. Experian is just like Equifax, but they do have the ability to keep watching the dark web on your behalf. So if they find any information that relates to you on the dark web, they tell you about it. So they're gonna kind of keep an eye on the dark web for you. So it's a service that they sell. If you're in the US, you can, take advantage of that. The best thing you can do if you think your information has been compromised is change everything. Start using your password managers. And start being more secure-minded. They're gonna say, I know Experian. Yes, use Experian. They're fantastic. I use them for a little bit and I stopped paying them a while back.
So do you mean the password manager in order to remember all the passwords?
Yep, password manager. This is what TL use, and this is what I recommend. Bitwarden. They have a free version, but they also have a paid version. I used to use LastPass. For individual, you can get the free version. And basically, it lets you create what we call a master password, just one password that you have to remember. And after that, you will use this to generate all other passwords that you're going to use for everything else, your Facebook, your social media, your bank, everything else.
I think Bitdefender, they have one because I have subscription for 3 years, right?
Which one? Let's Defender? Which one?
Bitdefender, yeah. So just
Oh,
give me one set.
okay. Okay. All right. What other questions do you have for me?
Yeah, Bitdefender.
Yeah, put that in the chat, Shukri. Put the resources in the chat so other people can have those resources as well.
Got a question, Mr. Professor.
Yes, Cass, go for it.
It's to do with your home labs.
Yep.
Do they just touch on, that? Do they just simulate the real life experiences with work environments and all that? Is that all it is about, or are there certain aspects of it as well that touches on some of the courses, some of the things we do on, with Security Plus and all the courses you have here?
Right, yeah. So it's all over the places. It's the most common skills that you will most likely, that companies will most likely like you to possess.
Oh, I see. That's
Yeah.
brilliant. That's great.
Yeah. So
That's
no
what I'm
matter,
looking to take advantage of. Yeah.
okay, yeah, that's the hands-on labs for cyber pros. This is what I wish I had when I got started. This right here, bring it up. This right here. So a bunch of labs where I showed you, common tools, and I like to run my mouth, so I'm there talking and telling you, this is how we use this, this is how we use this, this is how we use this.
Oh my goodness.
How long will it take for the recordings to hit the website? Usually about a day. So give us 12 hours, 24 hours. We will upload this today.
So $497 for the live access, is that what it is?
No, this is for the lab, for the lifetime access.
Yeah, what's the price of the okay.
It's the 49, and if you can get the membership, and that will give you access to that as well.
Right. But that would be a yearly thing if I was to go with this membership.
Membership is a monthly thing.
Oh, okay.
And the lifetime access is when, you say, yeah, one time and I'm done.
That's cool. That's a no-brainer on that one. All righty.
All right, guys, what other questions do you have for me before I let you go? Oh, announcements. We are now going to have a class next week. In America, we have Thanksgiving.
Oh, okay.
Yeah, so some of us are going to be spending time with our loved ones and eating a lot of food. So next time you see us here, we're probably going to be a little bit, fatter than we are right now.
That's right.
So yeah, no class next Saturday.
That's
Okay.
right.
Best certification for entering into cybersecurity from someone with technical background, having idea on the IT operation infrastructure management, basic networking, setting up infrastructure, was the best certification path to transit into cybersecurity.
Yeah, I will start with Cisco.
Okay.
Yeah,
Why Cisco?
start with Cisco because they basically own the networking side of things. So they're the one that deals with the routers. They're the one that does the SDN, the software-defined networking, SDN.
Okay.
So, and SDN is like the modern way of designing networks and infrastructure and things like that. So I will start there, but if you just want to focus on the cloud, like infrastructure in the cloud, then I would say just pick one cloud. My recommendation would be Microsoft Azure. Pick that and then focus on the infrastructure side of things.
Right.
All right.
But
Thank you.
definitely start with Security Plus. Like understand the basics
Mm.
Know your networking. Some people think if you migrate into the cloud, then the OSI matter, the layer 2, that stuff comes back. All of it still there. So know your basics.
Yeah,
Okay. Okay.
I think AWS right now, they have a free version too for the lab. Maybe they can create an account for 1 month for free. You can apply everything for the
You say
first month.
maybe they can create what? You were cutting off.
AWS, Amazon Web Service.
Yeah.
So he can create one free account for 1 month
oh yeah.
and
So
he can apply everything. So he
yes.
will know everything about, because AWS is more wide than the Azure Microsoft.
Well, so okay. Yes, to the question, to the thing that Shukri is raising here. Yeah, you can get a free tier. They all have it. Free tier for AWS, free tier for Azure, and I think Google has the same thing. It's a year access where you can play around with their tools. Now, you got to be very careful. I've been a victim of this because as soon as you go past the free tier, allow the max, they start charging you. Okay, back
Yeah,
to
if you put your credit card,
why
you can-
AWS but not Azure? Well, I'd say if you like to work with the startups, then go with the AWS. But if you want these mature companies, these healthcare, these manufacturing companies, they're all going to Microsoft Azure.
Microsoft. Yeah. That I understand now.
Yeah. So that's why I recommend Microsoft Azure, because there's that, stability. Besides,
Yeah.
AWS is very popular because once we talk about the cloud, I'll come back to all this, but they were the first mover. They had a few years before anybody else jumped into the game. But Microsoft have been catching up. They have a lot of great stuff too.
I actually have hands-on of both AWS and Microsoft Azure. On Microsoft Azure, I see manages virtual machines. I spin off virtual machines for users for production and all of that. For AWS, I have one EC2 that I'm working on EC2. I have one application that I hosted on EC2 that I am managing. So I feel more comfortable with Microsoft Azure because everything look more in one place. You can easily walk around everything, access everything. Maybe you have on-premise users who are using AD. You can move them to Microsoft Entra, syncing them, having direct single access to everything in your organization. So I have this basic knowledge about both, but I'm more comfortable with the AWS guy. Sorry, the Microsoft Azure guy.
All right, guys, what's your name? Harun?
Harun.
Yeah, Harun. All right, guys, look, you want to know more about Azure? Connect with the Harun.
Yes, boss.
That's a very good way to say it. Nice introduction right there. One last question from me, Prof. It's also to do with your course.
Yep.
It's particularly with your one-on-ones. Can you elaborate a little bit more on that aspect? What things you offer, the service you provide with one-on-ones?
Absolutely. So one-on-one, it's basically designed for you, customized for you.
For
So
me?
yeah, when I say for you, I'm talking about anybody who wants it.
Oh, so I'm like, oh my goodness, that's amazing.
Yeah. Yeah, so if you are struggling with labs and you say, you know what, I want to get more practical with this. I want to know how this will be used in the real world with somebody holding my hand. Yeah, you grab the one-on-one.
Right.
If you have a resume, cover letter that you want me to critique or you want me to help you design one, you grab one-on-one.
Okay.
Interview questions. You want me to beat the mean interviewer guy, and you want me to run through some identity access management interview questions or GRC interview questions one-on-one.
Okay.
So basically, you preparing for certification, and you want to hear my opinion, or you want to know what you should focus on and things like that. Hey, grab one-on-one.
Okay.
Some mentoring.
Thank you so much. Thank you so much. A quick one. Please permit me, or maybe on a weekly basis, I will be writing on things you are taking us, then pasting them on LinkedIn, putting your name on it. More like awareness to people on what you do for the community. Am I allowed to do that?
And you are. So reach out to me on Discord, and let's take this offline.
All right.
Thank you. Look at that.
Right.
More people are trying to help the community. Okay, guys, I am done. This is your time. If you don't have any question, I will shut this down and we can go start preparing the turkeys. Okay. Hey, Harun, how can we? Yeah. So, Harun, if you can paste in your contact information, maybe LinkedIn, not phone number, maybe LinkedIn, that would be great.
All right. It seems we had a little conversation before on LinkedIn. I will just drop a message for you on LinkedIn.
Sounds good.
All right. Thank you so much for the time. Talk to you
Thank-
guys. Have a blessed week.
All right,
Is it
Cass.
weekend? It's Saturday out
Everybody
here.
the same. Have a good one.
Have a great
Thanks a lot.
day.
Take care, Professor.
All right,
Take
guys.
care, guys. Take care. Talk to y'all later.
Everybody
Bye.
take care.
Yep. Happy
Thank you.
Thanksgiving.
Thank you, Professor. Have a great day.
Thank you very much, everyone. Happy Thanksgiving to everyone. US.
Yeah, try not to eat too much. Tell them that.
Thank you, Professor, again.
All right.